Good morning, everyone. This is for the kids who are in the SOS training. I'm sorry you could not be here today. This is Mr. Ahlers reporting from his classroom like normal. Today is 3/31/2021, and there is a warm-up that if you could complete, that would be great. Thanks so much. There's a couple of reminders. Tomorrow, A is going to Mr. Bauer's room for Thursday. And then B on Friday is going to Mr. Bauer's room. And this is going to be all the way from starting tomorrow through the following Friday, 4/1 to 4/9. If you have any questions, you can always email me. Please email me. I may not respond as fast as I normally do, but I will be responding. Trying to think. Tomorrow you have a skill quiz. So here's the calendar. So we kind of think. Here's the calendar for next week, which I didn't get this week. Upcoming is next week. You have a skill quiz on do a skill quiz on 9.1, which is going to be, sorry, it's loading. Still loading. The first one is solving quadratic inequalities, which is tomorrow. And then the next day is solving systems of nonlinear equations. So I think that's like a quadratic and a quadratic, or quadratic and a linear. So that's kind of what we're working on today. So, and then you have skill quizzes next week. So I'll send out a reminder for those. Yeah, so yesterday we left off with, we did this one where we had the line and then the quadratic where it intersected twice and got two answers. And then we did this one where we actually we solved it and we got an imaginary answer, which means that there's no intersections. So we're going to solve this one. So how many times did it intersect? Use an algebraic method. So essentially we set these two equal to each other. We have x squared equals 2x minus 1. And then I want to bring everything to the one side. I'm going to bring this to the left side. So I have x squared minus 2x plus 1 equals 0. This one's super nice. I think it factors to x minus 1 times x minus 1 equals 0, which is really just x minus 1 squared equals 0. So you could do this or this, and then you could say x minus 1 equals 0, x minus 1 equals 0, you get x equals 1, x equals 1, or you can do square root x minus 1 equals 0, and then x equals 1. Because these are the same, you only need one answer. So our answer is x equals 1. Be careful because sometimes they ask for the points of intersection, which means you need to plug in the x into the original equation. So y equals 1 squared, which equals 1. So then the point is 1, 1, which means there's one intersection. If you graph it, you'll be able to see there's exactly one intersection point at 1, 1. Go ahead and hit pause. And I want you to try solving B on your own. How'd you do? Nice job. I have no idea what the answer is actually. I think there's no solutions. So we'll see. I got x squared minus 5x plus 6 equals negative x squared. I'm going to bring this to the other side. So I got dos x squared minus 5x plus 6 equals 0. I don't think it's factorable, so I'm going to just use quadratic formula. So negative 5 plus or minus the square root negative 5 squared minus 4 times 2 times 6 all over 2 times 2, which is 5 plus or minus the square root of 25. I think that's 8. 48 minus 48 all over 4, which is 5 plus or minus the square root of that 23, negative 23 over 4, which is equal to 5 plus or minus I root 23 over 4. So there would be no intersections. If you graphed it, there'd be no points of intersection. All right. Important main ideas of 9.3.1 is the average rate of change, which is really just slope. So that's like your M. And remember, slope is y2 minus y1 over x2 minus x1 was M. So sometimes you have a quadratic. You have a point here. And the average rate of change is just the slope between 2 points. For 9.3.2, comparing growth of different functions. So some different functions that we might have is we have linear, quadratic, and then what's the next one? Technically, it is cubic. There's another one that we're looking at. I was actually looking for exponential, so I really set you up for failure there. I'm sorry. So the growth, remember, linear is a straight line, quadratic, exponential. And just know that this one is the slowest. This one is the fastest. Like, would you rather add, would you rather add like 10 cents every month? Or would you rather add like 10% every month? And of course, you rather add 10% because then it compounds on each other. So, all right, 9.3.3. Can I build a piecewise function? Do you want to build a piecewise function? I'll stop. So this is what they call a step function. So keep that in mind. So 9-102, the Horizon Film Company offers a basic monthly voice plan where the customer pays a low monthly fee, but they must pay extra if calls exceed the maximum number of minutes, which I think like when I was a child or like a young adult, this is actually how cell phone plans worked. By number of minutes and whatnot. So and the graph showing it right. So essentially, describe the plan in detail. How many minutes are included in the monthly fee? What is the charge for extra minutes? So for $40, the first 450 minutes are included. However, if you go from 450 to 451, you go up, I think that's like 50 cents. And you go up 50 cents for every single one. So for instance, $40. So we usually use this like y equals in this big bracket and then for our function. So for $40, what does your x value have to be between? 0 and 450. But the question is, do we include or not include? Because this dot is closed dot, you include. What happens now how does it become $4, $40.50? Sorry for the leaf blower. So it's between 450 and 451. But we don't include the 450, but we do include the 451. Go ahead and try to do the next one. This is $41. And what's the price going to be? Pause it here. Nice job. 451, non-inclusive x, inclusive 452. And then we could go on, so on, so forever. The question is this a function? Passing the vertical line test. Is there ever a point where it's intersected twice? So somebody said right here last year, but is this intersecting to that point twice? It's intersecting here in the dot, but is it intersecting here? No, because it's not inclusive. So this is, yes, a function. And this really is the answer for this one. But of course, so. And this is called a step function. So just keep in mind, this is called a step function. All right. So draw and complete the graph for the following piecewise functions. It may help you to make a table first. You can. I'm not. So let's graph this one. I'm gonna do that in red. So I'm gonna go down 5, up 2, right 1, 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 up 2, right 1. But looking at my bounds, what's the lowest possible x value? X has to be up, down 2, right 1, down 2, right 1. So it says x has to be less than 1. So that means I don't want anything to the left of that. I want my graph to be only over here. So I'm going to erase these points here. Second question is, does this dot a closed dot or an open dot? Yes, it's a closed dot because it's included. So I can graph my line. Then we do our quadratic. What's our HK? H is, are you sure it's not -3? Oh, it's because it's opposite. So it's in here, it's whatever the opposite is. So it's 3, 1. So I'll graph this one in blue. So we go right 3, up 1. And then remember, you just go right 1, up 1 squared, right 2, up 2 squared, right 3, up 3 squared. And then you can mirror it over. But remember, we only want when it's greater than 1. So we don't want this point. That point here. Question, is that point open or closed? Because it's not inclusive, because it's not inclusive, we want an open dot here. And then here's our piecewise function. Number 1 question. Does it pass the vertical line test? And it does. And it's 104. Elisa is training for a 5-mile run. One day she runs from her house to her friend's house, Anna's house, 2 miles away. Elisa talks to Anna for 10 minutes while she stretches and then runs home. Elsa runs at a pace of 1 mile in 10 minutes. Dang, that's like Mr. Allers' pace. On the way to Anna's house. On the way home, she's so tired she runs at a pace of 12 minutes per mile. Draw an accurate graph of the distance over time. So I think this is distance. And this is time. She runs for 2 miles to Anna's house. So I think it takes her 20 minutes. To go 2 miles. So I put this as distance, but I should have put this as distance from home. So after 20 minutes, she's 2 miles away. So there's our graph. And then from here, she sits there for 10 minutes. And she talks and stretches. So her distance doesn't change. And then after that, she runs home, but it takes her 24 minutes. So there's our graph. It's continuous because both time and distance are continuous. because time never stops, and then the distance never stops. Now write a piecewise function. So for the first part, we need to write this equation. So that's y equals, and then I think the y-intercept is b, there's 0 because it intersects here, and the slope is up to over 10, no, over 20, which equals 1 over 10. So it's 1 over 10x plus 0, so I don't need the plus 0. And the domain is x is between 20 and 0. The next one, this is just y equals 2, horizontal line. And that's between 20, non-inclusive, x, inclusive of 30. But technically, they share a point, so technically it's okay. But usually we don't include this ones. This is the second ones. And this one is the slope is down 2 over 24, which is negative 1/12. So that's negative 1/12 x. And then we need to find the y-intercept, which would be, I'm putting the point 330. So is that 2 equals negative 1/12 times 30 plus b is at negative 30 over 20, which is negative 1.5. Negative 1/12. Sorry. Which is 30 over 12 is, I think it's 6 goes in there, so it's 5 over 2 plus b minus 2 equals 2. Add 5 over 2 to 4 over 2, which is 9 over 2 equals b. So then it's plus 9 over 2 from 30 to x to 54. Here's your homework. Not too bad. Skill quiz tomorrow. I won't see you for a while, but you can always email me. The baby's supposed to come tomorrow, so thanks for watching this video, and I'll see you all in a little bit.